everyone to this class on information technology, and today now we'll be looking at system theory. So we look at what system theory is all about, how theories have been applied to all of the systems, the meaning of the systems. So we're going to look at subsystems in the system environment, and then we'll move on to um, control of the system. So what is then system theory? System theory actually consists of different principal concepts and some kind of rules philosophy that have been applied in the study of the system. So there are it's very key that we need to know more about how a system can easily be studied, what are the concepts that can be applied, what are the principles, the philosophies that needs to be applied, why to study a system. A system is very it's more like a whole of something, a kind of a whole that consists of different kind of elements. So in that regard, we need to um, study some kind of a system. Like for instance, a business system. In study of a business system, there are some concepts, a lot of principles, kind of laws, guiding laws and principles that can be applied to easily study such system. So in business system now we have some kind of different principle we can apply to have that study in the business system. And what happens is that in the business system, instead of different system, we can have different category. We can have the quality control system. We can have quality control system. We can as well have budgeting control system. We can have production control system. These are different category of systems in a business system, and there are some concepts that can be applied. So we call that the concept, the principle, we call them the system theory. Alright, so what is then the meaning of a system? A system is more of like a combination of different interrelated elements. We call such interrelated elements, we call them subsystem. And the subsystem must be organized to ensure proper functioning of the whole system. So the whole of the system consists of different elements, and then the elements are being compiled and then organized to ensure proper functioning and proper running of the whole of the system. A system can include, we can have business system, we can have information system, we can have computer-based information system, we can have manufacturing system, we can have stock control system, like that. So do not forget, in a business environment, in a business system, for instance, a business system consists of different interrelated elements. As a very good example, you can, in a business system, you can have different section, different departments. You can have audit department, uh, you can have personnel department, you can have finance department, you can have um and so on. You can have purchasing department and so on and so forth. So a business system, it's more of like a wide system. So the study of each of these components or elements that I mentioned as subsystem, this teachers critical study and their combination in how made up of this business system. You also have the business system that are made up of different parts or different subsystem as well. We have manufacturing system, we have the stock control system. Alright, so let's move to alright, so now the idea is that the various subsystem of a system are very important to its proper function of the system. So, and as well, it's very good that we make sure that what the objective of any particular system is known. For instance, it's key and important that to ensure that what happen, the objective of a particular system is known. For instance, the objective of a business system needs to be known, and how that objective can be easily be attained. It's very important and key that such objective is very well is easily identified. Let's say for instance, in a business system, the objective of a business system might be in form of profit maximization, to maximize profit and to ensure that what there is financial return for shareholders, and as well to maintain a high market shares, to improve on customer satisfaction, and to improve and develop the environment, and that is in recognition of its corporate social responsibility, and so on and so on forth like that. So that will be the objective of the system. And what happened is very key that such objective is being stated, and how that objective will be achieved must be known. Because once the objective of a system is being known, it will be easy to actually ensure that, okay, how can we then, couple how can we couple the subsystem together in such a way that we can ensure the proper functioning of the system, in such a way that they can easily ensure that what the aim and objective of the system is being easily achieved. All right, so let's talk about system environment. So we have our system environment. So what happens is that it's very key that we know that what happens in a system does not in any way stand in single thing. It interacts with other form of element, other component outside of it, and such component or element influence it in one way or the other. So such component or element is called environment of the system. So we call them system environment. So the system environment actually influence the system, and as well they interact with the system. So we call that the system environment. So we said that there is a need to consider the environment of a system to ensure proper running of such system. The environment of the system are elements that surround and interact with it. So they surround the system and interact with the system. All right. So for instance, in a business as a system, are you with me? So the government, the customers, the competitors, the suppliers can be a very good example of an environment. Why? Because all of these sets, the government, the customers, the competitors, they all interact with the business environment. They interact with it, they communicate with it, in determining the overall functioning of the system. So that is just the activity in a system environment. Now we need to know as well that, okay, in every system, what happens? What brings a system between a system and an environment, what brings them together? There is actually a boundary between this. Let's say, for instance, we have a business system here. We have a business system. Let me shorten the word. Let's assume we have a business system, and this exclosure, and this overall exclusion. This is our business system here. So every element here that's in between this boundary are simply the element of this business system. So when any element that are outside of it and the environment, so we can have government. Let's see, government is here. So they interact with the business system. We can simply have customers. So they also interact with it. We have customers. We have customers. We have competitors. So we have competitors. So we have competitors. So all of this determines the environment of the business system. So this boundary here actually starts at a link. And one thing about the most systems is that they become adapt. They must be adaptive to its environment. That it must be able to change its environment, be adapted to its environment, and change to its environment. All right. So one thing about a system is that when trying to explain a system, and the system tends to achieve its aim and objective as well, there might be some kind of limitation that will surround the system, and that doesn't mean it's be able to pass that. So through its environment, through the study of an environment, the business will be able to strive no matter what, and things like that. Okay, so we have been able to explain a system, the environment of a system. All right, so sometimes all of this environment can pose some kind of limitations to a system in terms of its in terms of its in terms of putting a constraint of some time. So how a business is able to deal with such limitations that is being put by its environment is very important. Let's for instance, in the business environment or in the business system rather, in its environment, there will be some constraint, some kind of disturbances that will arise from such an environment. Let's say for instance, there can be scarcity of resources from the environment, resources that will be used in the production department, which serve as a subsystem for the work for this business system. So in that regard, if such resources is not available, that is a limitations. That poses a problem to the work to the environment. So how does a system is able to achieve that? How is be able to plan and solve that problem is a key to the proper running and functioning of the system. Alright, we have a political and legal constraint. The government can put in some kind of laws, policies that will prevent the achievement or the achievement of the aim of the work of the business system, so that we can have product completion time. There might be a delay, technological advancement, and things like that. So let's move to the. So in this session we have what we call subsystems. We have explained that earlier on. We say the system consists of different interrelated elements. So and these elements we call them subsystems. So it's very, very important and key that the business is what will be able to actually break no different component element that made up of it, and how these are easily be able to study. It's very, very key. Alright, so we have it here that system is generally made up of different subsystems. So there is need to break down to its various components or elements. In fact, some subsystems can be further divided into subsystems. Subsystems sometimes interact with one another through communication and observation, which ensure that the whole system works efficiently. So subsystems communicate with one another, they actually interact with one another and things like that for the passing of information. Alright, so we can have different type of subsystem. So we have it in the manufacturing organization and the system. So in an organization that has a business system, they can have different subsystems there. They can have a subsystem personnel department. We can have marketing department as a subsystem. We can have audit department as a subsystem. We can have production department as a subsystem. We can as well have information technology as a subsystem in the organization. We can have maintenance department and okay. So these are the various subsystems we can have in that. We can also have purchasing and procurement department as a subsystem in such an organization. So these are the various subsystems that are available in such organization, and each of them interact with one another for ensuring that the whole of the organization function well. So there might be parts of idea that communicate. For instance, there might be some illusion between the personnel department and accounting or finance department or audit department. There can be some communication in an instance of personnel department and marketing department. Personnel departments actually train and make personnel available for the use of marketing department and every other department too. So there is some kind of interaction between them, and all of the major aim of that is just to ensure that what happens, the system function well and function properly. So just they tend to work in achieving the aims of the system. So let's move on now. We can move on to the next session. So we have the aspect of coupling and decoupling of the system. Coupling actually deals with we integrating the element of the system, and what happens, decoupling deals with disintegration. So when you integrate in the aspect of coupling, your word disintegrate in the aspect of decoupling. So coupling a system simply means the degree of dependence. So what is the degree of dependence of the system? So it shows the degree of dependence, the degree of interaction between the systems. It's very important that each and every element, subsystem of the world, interact with one another. So the degree of interaction or dependence between each department is what we call coupling. So and as well, it's very key to know how well each department or each and every department depends on one another. So the degree. So what happens is that is once that has been known, the degrees should not be too high. The degree of dependence should not be too high, because if it's high, it can pose a problem. It can put some kind of limitation, some kind of constraint on the whole organization. So the degree of when we are trying to integrate a subsystem together for the proper functioning of a system, what happens? The dependence or the essence of the dependence should not be too much, should not be too high. So let's say for instance, in the personnel department and marketing department, there will be some kind of dependence between them. Marketing department will need the help of personnel department in terms of providing personnel for the marketing department, sales department, sales representative, sales manager, everything. They all come from the personnel department. Marketing department also help to advertise and provide some kind of marketing information. So in that regard, if the degree at which marketing department depends on personnel department is 100%, let's say for instance is 100%, so what do you think will happen if the personnel department is not functioning in the organization? What automatically what happen? Marketing department as well will not function. So that simply means the degree of dependence or coupling subsystems together, if it's too high in an organization, what happens? That will lead to issues of complexity, issues of instability in the organization, and that can lead to the breakdown of the system. So that now leads us to the aspect of decoupling or disintegration. So there might be a need whereby what happens when we couple a system together, what happens? There will be a willing to actually disintegrate them, decouple them. So that simply means we tend to make them to be more independent. So what happens? We tend to the system to be more independent, and what happens to actually make them to be for the system stability, for ensuring that the system is stable and works so well. All right, so we can actually take this away. So and what is that, and then that is where we have subsystem work together for the overall purpose of the system. So what happens? Coupling the extent or degree of dependence amongst the systems. So the extent is that to avoid problem or complication, this subsystem must not be over integrated in the way where one element of the system does not function, otherwise other will be rendered useless immediately. So if one does not function, what happens? Other will be rendered useless immediately. Just like the instance we stated in the instance between the personnel department and the marketing department. So coupling the system should not be much. The degree should not be so high in such a way that over dependence of one subsystem will actually affect the whole of the system later on. So the coupling enables subsystem to be more independent, so as to ensure stability in the system. So you have to decouple sometimes, disintegrate them, so that to ensure that a system is able to stand on its own. So to solve the problem here between the personnel department and marketing department, is you can just simply say, okay, how can we easily solve the problem? Because okay, let's marketing department to sometime be able to procure, be able to employ with some degree of independence. You understand? Without the understand of personnel department, let marketing be able to procure his employee sometime, with advice, some kind of guideline authority, so little control that can help, that can actually give us a lead on the aspect of decoupling the system. So in a system of any kind, it's key to know how to actually decouple them and solve the problem easily. All right, so we talk about subsystems, all of the subsystems, the combination of them give us the system, and they all work together in the proper functioning of the system. In fact, these are different subsystems in the business organization. You know that in some subsystem, a subsystem can as well have a subsystem, another subsystem. Let's say for instance, let's give an example. In the production at the subsystem, production department at the subsystem, there can be some other subsystems under it. You can have machine operation control system subsystem at the system. You can have work admin subsystem, power supply subsystem, so and things like that. So it's very important that subsystem of a system can also have its own subsystem, its own component part, and all of it work for the proper functioning of the system. on that aspect. And let's move to classification of a system. So we can easily classify a system based on its logical description and physical description. So we're trying to classify a system based on its logical description is all about we're trying to state or look at the essential element of the system without we not focusing on how the system are being implemented. That is the aspect of logical description. But for physical description, what happened? Our focus is on the implementation of the system. How are they implemented? Let's say for instance, okay, we have the logical description of the system is a representation that specifies essential element irrespective of how this may be implemented. That is the logical descriptions. So don't forget on that aspect. And in the aspect of physical description, this actually focuses on implementation. It shows how each element of the system may be implemented in achieving the overall aim of the systems. That is what the aspect of physical description. That's what it's focused on. Let's say for instance, we can take an example or illustration on that. In the aspect of computer as a system, computer system, when we actually focus on computer system, so we can look at this logical description. The logical description we look at, okay, what are the essential elements, what are the elements essential, what are the logical order of the word of the element there in the computer system. Okay, we can list out the logical sequence or the logical order of what of the system that we're trying to specify the element, position of the element. Okay, in the computer system, you know that okay, the essential element there will be based on okay, we knowing the input system, having an input, we're trying to have an input. So in that system there must be an input. It will be must have and then the aspect of processing. And as well we must have output. Okay, so we must have output in the system. So this output, so we must have output. So there's this for input, then there's this for processing, and there's this for output of the system. So that is just the logical sequence here, logical order that needs to be followed in having the system. Now we have that. So then as well we can as well look at the on the aspect of physical description, which focus on implementation. So in the aspect of physical description, this logical order here, we are trying to define the essential element there in the aspect of computer system. So now there is a need for us to actually look at how has this been implemented. So for instance, for input now, what is the idea? We have the elements in the computer system. What is the idea of input? Okay, you know that okay, for us to implement an input, what happens? We can make use of different function. For instance, you can okay, there need for aspect of keyboard. You can make use of a keyboard. Let's say for instance, if you want to have an input in the computer system, if you want to input a word, you can do that. Then we need to make use of a keyboard. Maybe I want to have an input of the word or like a record of the words of the word fonts. That means I need the letter F. So I will need to have in the keyboard I will need to press the key F, the key O, the key N, the key T to have the word font. So that is the aspect of the implementation. That is how input is being implemented, and other things that need to be known like that. What are the things that are okay? Alright, so that is how input processing. Okay, how is the process, how is this being processed? Okay, how do we achieve the aim of processing this with the aim of converting inputs to outputs? How is that being achieved? Okay, we make use of the software and just like that. We are still on physical description. And output, how do we generate our output? What are the things that will be needed? How is the output being implemented? How is it being used? When we have an output, we already have an information. How is the information being utilized? That is the aspect of what into physical description of implementation. So just on the difference between the logical description of the system and physical description of the system. Now let's move to different type of system. We can actually categorize a system based on how they interact with their environment. So we have basically two types. We can have an open system and a closed system. So in the case of an open system, it's a system that interact with the environment in the collection of information. They interact so well, they adapt to changes in their environment. Such a system is an open system. A very good example is business system. But business as a system, business interacts with its environment in the collection of information. For instance, in the business system, what happens? It interacts with generation of information from the customer, information through interaction. Information will be obtained from government, from different. Just think of it, different um, um, elements of the environment. So suppliers and stuff like that. So that's just the idea of an open system. It interacts so well. It adapts to changes in the system. But a closed system does not in any way interact with the environment in the exchange of information. So it does not in any way interact. It does not. It is not open. It is not open to to its environment. So short system neither accepts input or give output. Either it is self-contained. But I will tell you, in reality, it's very difficult for you to have such a system that will neither not interact with the system, not take and not give to the environment. Such it's very difficult. But what happens? We need this content. We use in in identifying some system that actually partly interact with their environment. Either we really make use of we apply the open system. Now let's look at classification of an open system. What are the degree of interaction reaction? We then to what is the degree of reaction of an open system with environment? So we have the degree of reaction. We can have deterministic, mechanistic open system. We can have probabilistic or stochastic open system as well. We can have adaptive or cybernetic open system. Alright, for deterministic or mechanistic open system, what happens is it's in one way or the other react from it with its environment, and the degree of reaction is that what happens is that it will follow some kind of laid down rules, some kind of regulations. You understand, some kind of laid down procedure in generation of its output or results from the environment. And in that regard, what happens? The result from such environment or the result that is to be obtained, since it's following some kind of laid down rules, we go to do some kind of it can be determined. You understand? Can be determined some kind of certainty. So certain that this is the result that will be accepted. So that simply means we can parallelly what happen know the result that will be expected from such a system. You understand? Once it's started with its environment. So example of a very good example of that system is the computer system. And when you have in the computer environment or in the computer, when the computer interacts with its environment, you understand there is a laid down rules. There has been some laid down procedure through coding, through programming, in such a way that by the time the environment interact with the computer system, the result that will be obtained can easily be determined. So we call that to be deterministic and mechanistic open system. So by the time the environment interacts with the system, what happens? The result to be obtained is so certain. So that is an example of a computer system of a deterministic system. Just look at you yourself as a human being. You have a computer. You are an environment that interact with that computer system. So the computers at the system have some kind of program, some kind of laid down rules. You understand? Some kind of procedures that have been stated in form of a command, in form of program. So in that regard, we call them software. If you come there and interact with such a program by trying to generate something from it, to influence it, if you know that what happened, the results you are going to expect, you can determine that yourself. with some kind of accuracy and what uncertainty. That is the idea of deterministic. So deterministic has gone. We have been able to explain deterministic. Now let's look at probabilistic and or stochastic. Now this type of open system deals with probability. I think by the time the environment influence them, the environment impact on them, we cannot in any way determine the actual result. We don't know what it's going to result to. The output cannot be determined or cannot be predicted with certainty. So what we come from such a system, we cannot predict with certainty. We cannot be sure. We cannot be certain of the output. So such system we call it probabilistic or stochastic open system. So the result that will be obtained from such system is not with some kind of accuracy or with some kind of certainty. We can't predict. And the aspect of cybernetic or what is it called, or adaptive system, this system actually what interact with the environment, and become adaptive with it. And what happen, and the then obtain some kind of stimulus. So what is going to give a become of stimulus based on what actually obtained from the environment. So that system is cybernetic. Is cybernetically retrieve some kind of that is it output from its adaptive nature of the environment. So whatever it gives from the environment is it's from itself, it's from the on basis. So an adaptive system responds to changes situation by adjusting its behavior on a self-organizing basis. So that's just the aspect of adaptive or cybernetic system. Let's move on to the other aspect. So we can have control of the system. Controlling the system is very, very important. It's key to ensuring what the proper function of the system. Because it's not possible. It's like you yourself, you can experience some kind of disturbances. You can have some kind of deviation. You understand? So there's that also applies to a system. So there might be a need to actually have in place. There will be a need to actually have in place some kind of control that will actually prevent a system from actually experiencing some kind of disturbances. The first look at, okay, we said that a system must be controlled to keep it steady and enabling it to change safely. So sometimes disturbances may arise and therefore affect the outcome of the system. So control is required to avoid disturbances in the system. So it's very, very important to be able to control the system. And in that regard, there are some elements that needs to be followed. There needs to be in terms of planning, in terms of you collecting data, making some kind of comparisons, and you trying to take some kind of corrective actions. And I'm pretty sure everyone listening to the videos must be one way or the other a management individual. So being a management, you know that okay, there will be a need in the aspect of control, there will be a need to actually plan and try to collect data and then make a comparison between your standard and plan and the actual, with your standard of plan and the actual. Once you can compare that, you compare, there will be what we call some kind of disturbed errors or deviations. So when you compare the deviations, you tend to know if it's significant or not, and what are the necessary actions that needs to be taken to actually prevent that and correct that. Alright, so let's look at the various elements of control. The first element of the control is that you have to plan. That is key. And why planning? Planning actually involves what? What planning is all about is that okay, you need to state the objective of having a system, and what are the actions that need to be taken to actually achieve the objective. That is the aspect of planning. Determination of objectives, the steps, actions that need to be followed in achieving that. Alright, so let's take up for instance in a business, when we have in a business organization or in a business system. Wow, look at our objective is to have a profit, to maximize profit or to make profit. Okay, making of profit, or as well I can call it profit maximization. Okay, our major aim is profit maximization. okay, yeah. Maximization. Okay, let maximization be the aim. Profit maximization is the aim of such a business system. Alright, so in achieving this aim, there's some kind of actions that need to be taken. Like for instance, the business, we need to know, okay, this plan, have standard in some kind of subsystem. Like for instance, we need to look at what is the standard time for operation in the system, what is the level of production activity required. You need to state them, level of sales required, maximum expenditure allowed. All of these are the elements of profit here. These things are very important in achieving profit, the objective of profit maximization. So when you have a plan, you have a predetermined standard. These are the standard for each of these levels. Then you can move on to the next element, the element of collecting facts. So you tend to gather data, the actuals. So you need to have an actual, and these are, in this example, the actual can be in the form of we trying to have the actual times taken. Then we have what you have already said, the time for the organization. What are the actual time taken? Put that down, collect data on that. So in the system, level of production achieved, level of sales achieved, the expenditure incurred. You understand, and you have already stated the maximum expenditure that is allowed to be achieved. And the next thing is for you to make comparison, compare. Wow, why is this is the standard time that has been set? This is the actual times. Wow, the actual time is more than the standard time. That simply means, wow, that is actually is bad. So you will be you'll be surprised, and okay, this is actually some kind of negative deviations. How can that be corrected? You think, all right, so this actual is more than the standard, is not a favorable one. You know, it can affect the system in one way or the other. It can affect us in achieving the profit maximization. Okay, level of production achieved. The level of production achieved actually that we have is not up to the level we have set. That is, that is very poor in the production department and the subsystem in the business system. All right, you can look at level of sales achieved as well, which might be the responsibility of sales department. The expenditure incurred, if the set standard, the standard here according to plan is less than this, and this is a positive one, it's okay, it's fine. You get that? So, but if the actual here, the data you collected, you see that by the time you collect data or information on expenditure incurred, and you see that it is more than the maximum expenditure that you have stated in your plan. So that is more of like the error, deviations. So next step is that you now think of, okay, what are the corrective actions you need to take? How can you correct that? How can you make correction to that deviation, so and things like that. So and think that is all about control, how you can effectively control a system. Now let's look at the aspect of open and closed looped control system. So in the control of the system, for our open loops, we usually have in an open loop control system, we usually emphasize on our emphasis is kind of the result of the system. Yeah, whenever we emphasize, we do not in any way depend on the result of the system. So in an open loop system, what happens? By the time we are emphasizing on the system or emphasizing on controlling the system, the result does not determine the result that is expected to be obtained from the system does not determine the side that we emphasize on the system. Example is automatic light switches, traffic light. Yeah, because what happens? The result that will be obtained from them is not as a result of emphasis, does not determine the emphasis that will be laid on the control of the system. So the result does not actually determine them. So the result is so certain. I hope you get that. So in a closed loop control system, what happens? The system that will be emphasized is based on the output. An example is when we talk about the business system, and such that output can also be can serve as a feedback as to the system as input. So you can later use them as input. So just like for instance now, when we have in our business system, is example of a closed loop system, because all of the output determine the emphasis, and by whatever output we have can serve as what, as a feedback as input into the system later on. So by the time you compare this and this, you know what there has been deviation. So this actual later on can serve as a form of what, as a form of plan for later, for later reference and just like that. So besides just the idea of closed loop and open, in an open loop, emphasis is regardless of the word of the result, and here emphasis is on the output or result because it helps to serve as feedback. So let's move to the last section, which is on feedback control system. So in the feedback control system, we have 3 areas we have to focus on. We have the aspect of okay, business information is needed to plan, make rules. Sometimes the plan or targeted aim may not be the same with the outcome as a result of errors or deviations. We have said that under the aspect of control. So there might be a difference between this. So the comparison between the actual and planned performance in the system serve as feedback. So it serves as information. So for a negative feedback, what happened? By the time we compare the plans and actual together, what happened? We see that there has been some kind of unfavorable deviation, unfavorable feedback into the business. So that simply means the actual in the case of expenditure, the actual is more than the planned. So in the business system, that has been a problem. It's not favorable. Maybe for instance, in our plan of having a good or favorable sales level, if we see that the actual is more than the plan, wow, that is a favorable one. That is not negative. But if the actual later on is less than the predetermined or the planned, that is not any way favorable, and we call that to be negative feedback. So we have a positive feedback as well, which is the opposite of negative feedback. And in the positive feedback, what happens? We have favorable one, whereby in an expenditure, the actual is more than the planned one. In case of expenditure, the actual is less than the planned, and in case of revenue, the actual, in case of expenditure, the actual is less than the plan, and in case of revenue, the actual is more than the plan. All right, so the third one, I said there are 3 in number. We have the feed forward control system. In the case of the feed forward control system, so the management can actually act proactively on the feed forward principles. And what happened? The principle is based on the fact that what happened, the errors or deviation that have been generated from the system are being compared over time, and that can serve as a monitoring process for the system, and that will be monitored over time. Deviation will be monitored, and what happened, that can serve as a feedback in achieving or in ensuring that there is a good or expected feedback in future or in later in later period. Let me just put it that way. All right, so that is all. We have been able to look at what a system is, what make up of a system, how to control a system, the need for coupling a system, and the need for to decouple a system. All right, so we have been able to look at the system environment and other things like that. So thank you very much. So expect more from us. So our next will be on data and informations, and how information have been collected, how data have been processed into information, the use of the logical tools of computer system, computer calculation and things like that, using a binary and things like that. We're doing the next class. Thank you and take care of yourself. Bye.